code 1224, the maximum equal frequency. This is a very interesting hard problem. So we are given an array nums of positive integers, and we are required to return the longest possible length of an array prefix of nums so that it is possible to remove exactly one element from this prefix so that every number that has appeared in it will have the same number of occurrences. So we are given some examples. Let's work through this example one together. So here we are given a nums array. It's 2, 2, 1, 1, 5, 3, 3, 5. So the output is 7 because for this subarray, if you look at here, so for this subarray, if we remove number 5, then all the other items appear exactly twice. So we can remove exactly one element and make all the rest of the element appear equal times. Okay, so this is what this question is about. It's a question asks us to output the longest length. So the index here is 6, and we'll output index plus 1 is 7. And the constraints are the nums are pretty a large number. It's 10 to the 5th. So we will think of like a linear or a log n algorithm, and each number is positive, larger than 1, and smaller than 10 to the 5th. So in order to solve this problem, we need to find a way to remember the counts of each element, right? Then we will need to dynamically modify this count, right? So in order to do that, one way to store is actually using a set. For example, if we use the STD set and of something, then it stores a list of numbers with its count. For example, for this nums, we for the entire nums we will store like 2, 2, 2, 1, 2, 2, 1, 2. So this is number 1. Well, this is number 1's count. And 5, 2. 5 is 2 times. 3, 3. It stores these values, and ideally we want to sort them according to its frequency, not according to the number, right? It doesn't matter which number comes first or second. What we care about is the frequency. We want to sort the frequency. Then we can compare the first element with the last element. If they have the equal frequency, then we know everything in this set has the same frequency, right? There's a fact that if the set begin and begin element has same counts, then all elements have same counts, right? And so we can actually use set, then we can check from the back to front. So whenever we find if we remove some item and we satisfy this condition, then we are done, right? So before we remove that element can only appear at the front or at the back, right? The element we will remove is either at begin or begin. This is another very important observation. Having this observation, we can actually write code to solve, right? So we define the node, struct node. So this means the type we put in this set is just a node. And inside each node we have the value and count. And we have a constructor. We input value and count. Then value will be set to val, and count will be set to count. And no other thing needs to be done in the constructor. And we need to have an operator. Operator less, because we need to compare inside this set, right? We need to have an operator, other node. We try to call that other. Oh, this is node, right? And this is count function. So if count equals other count, it doesn't matter. So we just return val less than other val. We need to have this condition because if you just compare count, then if the two have the same count, the value will override each other, right? So for this set to determine, it must have some total order. Then we just return count less than other count, and that's it. Then we can define this set. So for example, if we define the set as node equals, we can actually try if we write the what we write is grammarly correct. So we first check if this is right. We put this in this set. Then for each element in this set, we output x val and x count. Okay, let's have some simple test. So when we output 1 2 2 2 5 2 3 3. Yeah, it's sorted according to the frequency, and the same frequency will be sorted by the value. It seems correct. Then yeah, nice, we can continue. So we have this set. Then so remember, if we remove our pointer from the back to front, then at each position we need to delete some item from this set. But set doesn't support random access. So in order to do that, we need to just find the number, the node, with the same value and count. Then we manually delete it. In order to get the value, it's simple, just the position, nums I is the value. However, in order to get the count, we need some other data structure. We need to have an ordered map to store the value and count. This value, this is count, right? Then we, for each item, put it into this hash with its count, right? And for each element inside this hash, we will put it inside this set. Yeah, then we have done with the initialization. We can do the actual work. In order to do the actual work, we loop from the back. Nums size -1, I larger than 0, -1. Remember that you cannot write size t here, because for size t it's always larger than 0. You will have an infinite loop. So we use int here, although you may have some warning. Then what's next? Then we first check if condition satisfied. Then we update our set and hash, right? So we first write this part because this part is easier. Then we check the condition. So in order to update set and hash, what we need to do is to decrease. So let's say t is equal to names I. Then we will decrease this one, right? But before we decrease, we need to have its count and try to find it from the set t and tc, right? This is where we find it from the set. Then after we find, we immediately erase it. And if tc is larger than 1, we will add it back. Because the set, you cannot directly modify its element. You just remove it and add it back, t and tc minus 1, because it's deleted by 1, right? And hash t will decrease. And if tc is larger than equals to 1, then hash erase t. Okay? Then the update part is done. Then we need to check if condition is satisfied. How to do that? Suppose this is the set, and we need to consider four pointers to consider. It is the first pointer, the second pointer, and the second last one, and the last pointer. So we need to consider those 4 pointers. f1 equals to st begin, and g1 equals to str begin. So this is the first one and last element inside this set. Then we need the second one and the second last one. f2 equals next f1, and g2 equals next g1, right? Then we can do the compare. We have several situations. The first situation is the first one is a 1. So f1 count equals 1. And yeah, for example, of course, before we do all the actual check, we can check some edge conditions. For example, how about this? If the size of st is less or equal to 2, less equal to 1 actually, we know that the condition will be satisfied, right? Because we only have one item with its count inside st. And also, if I is less equal to 2, you can return, because for this condition there are maximum 3 numbers inside this set. So if we have only 3 numbers, we remove one, we have 2, then those 2 will either be identical or different. Either way, it satisfies the requirement. Okay, now let's see. So for example, f1 count is 1. Then what we do here, this means we can remove as f1 count, right? We need to check f2 count and g1 count. Okay, and if this is also true, we can return I plus 1. How about f1 count is larger than 0? If it's larger than 0, we need to compare f1 minus 1. This should be equal to f2 count, right? And also f2 count should be equal to g1 count. Then we can return I plus 1. Okay. And the third condition is we consider the last element, g1. The last element, if g1, do we need to consider the g1 equals 1? No, because g1 is always larger than f1, right? Larger or equal to f1. And if g1 is 1, then we know f1 is for sure is equal to 1. Then we have already considered this situation. So now we know g1 is greater than 1. So we will compare g1 minus 1. It should be equal to g2 count, right? And also g2 count should be equal to f1 count. This can make all the elements inside this set equal. Then return I plus 1. Yeah, I think that's it. Let's see if it can work. Yeah, it seems it works. And we'll submit. Okay, so it passed. And this is the implementation. It's the main idea is to have a set to store all the node value and its count, so that we can modify this set in logged in time. Then we use this hash because when we remove some element, we need to know what its count. So we dynamically modify the set and hash, and we search from backward. And whenever the condition is satisfied, we will return. Otherwise, we keep searching. Yeah, and I think that's it. Thank you for watching, and see you next time.